Hotep Congo Nation, I'm Sister Johnson and welcome to our math lesson. Today is Thursday, May 7th, 2020. Since it's Thursday, not only are you going to attend math and science class, but directly after at 12:30, you have been invited to participate in the Congo Nation recess. Brother Issa is going to host that recess at 12:30 p.m. today. The link to the Zoom recess has been sent to your email and it's also been sent to your parents. All right, so we hope that we will see you today at 12:30 at our recess period. There you'll be able to catch up with some friends that you haven't seen. Immediately after your recess, don't forget, you want to go to your physical education class with Sister Sabrina. Yay, Bo? All right, Congo Nation, to begin our math lesson, I want to introduce you to Seshet. Seshet is the ancient Egyptian symbol of knowledge, wisdom, and writing. She is the matron deity over 7 scientific professions, including mathematics, accounting, architecture, astronomy, building, surveying, and timekeeping. Seshet has held many titles, including Foremost of the Builders, the Lady of Fate, the Mistress of the House of Books, and the Lady of Years. So scholars, now that you know who Seshet is, going forward, we are going to refer to this class as our Seshet lesson. Now let's take a look at our application problem. Application problem. Sister Isaiah drew 7 circles. Sister Sutton drew 12 squares. How many fewer shapes did Isaiah draw than Sutton? Congo Nation, please pause this video and copy your application problem into a new page of your composition book. Once you're finished, you can resume this video. Welcome back, Congo Nation. Thank you for copying your application problem into your composition book. Now let's reread the application problem together. Yay, Bo? All right, Moja and Billy Tattoo. Application problem. Sister Isaiah drew 7 circles. Sister Sutton drew 12 squares. How many fewer shapes did Isaiah draw than 7? Yay, Bo? All right, Congo Nation. We want to begin by annotating our word problem. Yay, Bo? All right, if we use our cube strategy, we know that our first step is to what? Very good. Circle key numbers. Who can tell me our first key number? Thank you, Brother Quadir. Our first key number is 7. So I'm going to circle this number 7 here. Yay, Bo? All right, who would like to give me, excuse me, who would like to give me our next key number? Very good, Brother Nasim. Our next key number is 12. Do we see any more key numbers in our word problem? Yes or no? Very good. No, we're finished with our step 1. Our second step is to underline our question. So let's underline our question. Find your question mark, Congo Nation. We know that each question ends with a question mark, so that's a symbol that we can look out for. Our question mark is here. I'm going to go back to the beginning of that sentence. I also see a question word, how, so I know that's my question. How many fewer shapes did Isaiah draw than Sutton? All right, Congo Nation, so this is very similar to the problem we did when Brother Rayvon and Brother Shaquan drew their triangles. And we compared how many they had, the difference between Shaquan's total and the difference between Brother Rayvon's total. Because we wanted to know how many more shapes Brother Rayvon drew than Shaquan. This time, according to our question, we want to know how many fewer shapes Isaiah drew compared to Sutton. So we're going to do a tape diagram once more. Yay, Bo? All right, so to begin my tape diagram, of course, I want to use my key numbers and see what I'm drawing, right? So if we talk about Sister Azaya, what did she draw, Congregation? Very good. She drew circles. How many circles did she draw? She drew 7. So we're going to begin by drawing those 7 circles. Please count with me. And of course, you're scribing inside of your composition book. Moja and Billy Tetu. 1, 2, 3, 4, 5, 6, 7. Yebo? All right, Congo Nation, do I want to label these circles? Yes or no? Yes, I do. I want to label it with an A, which represents Sister Azaya. And to make it a tape, of course, I have to draw that rectangle around my circles. All right, we've created Azaya's tape. We have the first step of our tape diagram. Now we're comparing the amount that Azaya has to Sister Sutton. So my first question is, what did Sister Sutton draw? Very good. Sister Sutton drew squares. How many squares did she draw, Congo Nation? She drew 12. We want to represent that in our model. So let's go ahead and draw Sister Sutton's 12 squares. But before we begin, I have another question. Even though they are different shapes, do I have to line up Sister Azaya's shapes with Sister Sutton's shapes? What do you think? Yes or no? Very good. Yes, I still have to make sure that each shape lines up. So I'm able to see how many are left over. Yabo? Very good. I want to be able to see the difference between their 2 shapes. All right. Let's begin by drawing our 12 squares. 1, 2, 3, and I'm being careful to line their shapes up. 4, 5. This kind of looks more like a rectangle because the sides aren't the same, but that's okay. We're going to show that they're squares. 1, 2, 3, 4, 5, 6, 7. And I continue. 8, 9, 10, 11, and 12. Yabo? All right, but it wouldn't be a tape without the rectangle around it. So I'm going to draw a large rectangle. Stand. I'm going to draw a large rectangle around Sister Sutton's 12 squares. Okay, and what's my next step, Congo Nation? Very good. I also want to label Sister Sutton's tape with an X, so I know who those squares belong to. Yabo? All right, now that we have drawn our model, let's return to our question. Moja and Billy Tetu. How many fewer shapes did Azaya draw than Sutton? Did Sister Azaya draw fewer shapes than Sutton? Yes or no? Yes, she did. Very good. Azaya drew 7, which is less than 12. So what we want to find is how many less did Azaya draw than Sutton? We need to figure out what this number is. Yabo? And the way we can do that is we can go where Sister Azaya's circle ends, draw a line down to Sister Sutton's squares, and then we know that what we have here will be our answer. Yabo? All right, so let's count. Let's see how many fewer shapes Sister Azaya drew than Sister Sutton. Moja and Billy Tattoo. 1, 2, 3, 4, 5. I'm going to write 5 here. Yabo. All right, let's do a number sentence. Let's do a number sentence that matches our model. All right, Congo, I'm going to find the difference between Isaiah shapes and Sister Sudden shapes. So I know I'm going to use subtraction. When we do subtraction, what number should we start with? The 12 or the 7? The 12, very good. We always subtract from the larger number, Yabo. So 12 is our larger number. That's going to be my whole number in this number sentence. And then my operation is subtraction. So what symbol do I need? Very good. I need a minus sign. And how many am I subtracting? Very good. I'm going to subtract Isaiah's, which equals, let's find out by counting back. Put 12 in your head. We're going to count back to 7 and see how many we have on our fingers. Moja and Billy Tattoo. 12, 11, 10, 9, 8, 7. What's our answer, congregation? 5. Very good. And 5 matches our model, so we know that we are correct. Yabo? Very good. Isaiah's 12 shapes minus Sister Isaiah's shapes shows that there's a difference of 5. Yabo? Sister Isaiah has 5 fewer shapes than Sudden. Let's go ahead and write our statement. I'm going to write it here because that's just where I have some room. You can write yours where you have room. You can write yours underneath your number sentence because I know you still have room on your page. All right? But the answer to our question is Sister Isaiah, and you're going to stretch your sentence across the page. Yabo. All right. Sister Isaiah has 5 fewer shapes than Sudden. Yabo? All right, good work, Congo Nation. Let's move on to our concept. Today's concept is to tell time to the hour, which brings me to today's mathematician spotlight. We are going to spotlight Benjamin Banneker. Let's learn more about him. Benjamin Banneker saw astronomical patterns from which he could make calculations and predictions. A mathematician and astronomer, Banneker was born November 9, 1731. Largely self-taught, Benjamin Banneker was one of the first African Americans to gain distinction for excellence in science. Congo Nation, you are about to view a video on Benjamin Banneker. As you're watching the video, I want you to keep your 2 comprehension questions in mind. Question 1 is, who was Benjamin Banneker? Question 2 is, what were his contributions to math and science? Once you're finished viewing the video, you are going to have 10 minutes to answer those questions. You can use your 10 minutes to look over your notes, to rewatch the video, and then to answer your questions. Yabo? All right, let's view our video.
Sometime in the early 1750s, a 22-year-old man named Benjamin Banneker sat industriously carving cogs and gears out of wood. He pieced the parts together to create the complex inner working of a striking clock that would, hopefully, chime every hour. All he had to help him was a pocket watch for inspiration and his own calculations. And yet, his careful engineering worked. Striking clocks had already been around for hundreds of years, but Banneker's may have been the first created in America, and it drew fascinated visitors from across the country. In a show of his brilliance, the clock continued to chime for the rest of Banneker's life. Born in 1731 to freed slaves on a farm in Baltimore, Maryland, from his earliest days, the young Banneker was obsessed with math and science, and his appetite for knowledge only grew as he taught himself astronomy, mathematics, engineering, and the study of the natural world. As an adult, he used astronomy to accurately predict lunar and solar events, like the solar eclipse of 1789, and even applied his mathematical skills to land use planning. These talents caught the eye of a local Baltimore businessman, Andrew Ellicott, who was also the Surveyor General of the United States. Recognizing Banneker's skills in 1791, Ellicott appointed him as an assistant to work on a prestigious new project, planning the layout of the nation's capital. Meanwhile, Banneker turned his brilliant mind to farming. He used his scientific expertise to pioneer new agricultural methods on his family's tobacco farm. His fascination with the natural world also led to a study on the plague life cycle of locusts. Then in 1792, Banneker began publishing almanacs. These provided detailed annual information on moon and sun cycles, weather forecasts, and planting and tidal timetables. Banneker sent a handwritten copy of his first almanac to Virginia's Secretary of State, Thomas Jefferson. This was a decade before Jefferson became president. Banneker included a letter imploring Jefferson to embrace every opportunity to eradicate that train of absurd and false ideas and opinions that caused prejudice against Black people. Jefferson read the almanac and wrote back in praise of Banneker's work. Banneker's correspondence with the future president is now considered to be one of the first documented examples of a civil rights protest letter in America. For the rest of his life, he fought for this cause, sharing his opposition to slavery through his writing. In 1806, at the age of 75, Banneker died after a lifetime of study and activism. On the day of his funeral, his house mysteriously burned down, and the majority of his life's work, including his striking clock, was destroyed. But still, his legacy lives on.
Scholars, now it's time for you to complete your 2 comprehension questions. Number 1, who was Benjamin Banneker? And number 2, what were his contributions to math and science? Please take the next 10 minutes to complete these questions. Remember, you can re-watch the video and take more notes. Congo Nation, let's begin our lesson. My first question is, what shape do you see on this paper? Very good, you see a circle. And on the circle, there are dotted lines all inside of the circle. What do you notice about the dotted lines on the circle? Okay. Very good. All right, so I heard that you guys noticed that there are 12 of them. Okay, actually, are there 12 of them? Let's count the lines. 1, 2, 3, 4, 5, and 6. So it looks like there are 12 lines, but there's actually just 6. What else do we notice? Okay, we notice that they look equal. Yeah, it looks like this circle might be made of equal parts. What do you guys think? Yes or no? Very good. I think yes too. I think that this circle is made of equal parts. Let's see how many. I'm going to see how many by starting at this top line, and then I'm going to count as I go around the circle. Count with me, Congo Nation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Very good. So that's why we thought that there were 12 lines, because there are 12 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Very good. All right, Congo Nation. So we know that there are 12 parts. We are going to color in each of the parts. But first, let's use our pencil, and I'm going to use a marker, to trace around the edge. And just as we get to the end of each part or section, I'm going to write down a number. Yay, Bo? All right, so I'm going to start here. And again, I'm going to trace over 1. I'm going to write 1 here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. How many equal parts are labeled on this circle, Congo Nation? 12 of them. Very good. Does this look like something you've seen before? Yes or no? It looks pretty close to something I've seen before. But usually, these numbers here are on the inside. What does this remind you of, Congo Nation? A clock. Very good. Yes, we are making a clock. And later on in the lesson, I'll show you, a better version of this clock. It'll have the numbers on the inside. And we call that type of clock an analog clock. Yay, Bo? All right, Congo Nation. So I am going to color in the 12 parts so we can see them more easily. I'm going to alternate between each part. So I'm going to keep this part white and color this part yellow. Then keep this white, color this yellow, and I'm going to continue around our clock. Yay, Bo? All right. All right, Congo, so we have our clock here. I'm finished filling in our parts, alternating between white and orange because I couldn't find yellow. And I added the numbers 1 through 12 inside our analog clock. So if we think about a clock, Congo Nation, are we missing anything from our clock? What are we missing from our clock? Very good. We are missing the hands. And on an analog clock, there are 2 hands. We have an hour hand and a minute hand. Yay, Bo? Let's take a look at the definitions, or how we define an hour hand and a minute hand. The hour hand is the short hand on an analog clock. The minute hand is the longer hand on an analog clock. All right, Congo, so we have our hour hand, which is green, and our green and short. And then we have our minute hand, which is longer, and it's going to be blue today. Yay, Bo? All right, so we know that our minute hand and our hour hand go here in the center of our clock. Yay, Bo? So I'm going to go ahead and position it, our minute hand and our hour hand, where it belongs. Just like that. Yay, Bo? All right, let's put our minute hand and our hour hand there. That time when our minute hand and our hour hand are on 12 is 12 o'clock. Can you say 12 o'clock? Very good. 12 o'clock. or midnight. We also refer to that as midnight. Yay, Bo? Every time that this minute hand is on the 12, we will say the hour and then o'clock. So when this minute hand is on 12, that represents o'clock. Yay, Bo? At 12 o'clock a.m. or midnight, we begin a new day. As this minute hand spins around the clock, so does the hour hand. Not as fast, but it does begin to spin like this. And as this minute hand goes completely around the clock back to the number 12, a new hour begins. Yay, Bo? This hour hand is now on the 1. The minute hand is on the 12. How do we read the time? How do we read that time? Very good. This shows us 1 o'clock. Yay, Bo? The hour hand is pointing to the 1. The minute hand is pointing to the 12, which means o'clock. We've reached a new hour. O'clock. O'clock is the time when we get through a full hour. The minute hand is on the 12. Yay, Bo? All right, Congo Nation. So let's look at the clock as it goes through another hour. Yay, Bo? And we know that this is speeding up an hour because an hour takes way longer than minutes. But I'm just going to show you what it looks like when this minute hand starts at o'clock. Time passes. It goes completely around the clock and a new hour begins. Watch this. As this minute hand comes around the clock, the hour hand would begin to move. Sorry, guys. It reaches back to the 12, and our hour hand has moved to a new hour. What is this time, Congo Nation? Very good. It's 2 o'clock. When we say the time, we start with the hour. Yay, Bo? What number is the hour hand pointing to? Very good. It's pointing to the number 2. When this minute hand is at the 12, what do we say? O'clock. Very good. So, if the clock looks like this with the hour hand on the 2 and the minute hand on the 12, it is 2 o'clock. Yay, Bo? All right, scholars, you're doing pretty well so far. Let's continue. Now, our hour hand is positioned at the 3. Our minute hand is positioned at the 12. What is this time, Congo Nation? Very good. It's 3 o'clock. Take a look at what it looks like on a digital clock. This is how we see 3 o'clock on a digital clock. The kind of electronic clock you see on a microwave, an oven, a cell phone, or a computer. We see the hour first. Point to the 3, Congo Nation. Very good. No extra minutes have passed. So now point to the zeros. What time does this digital clock show? Very good. It shows 3 o'clock. The hour is on the left of the colon, and the 2 zeros, which represent o'clock, are on the right of the colon. Yay, Bo? It's in the order if we read from left to right. We begin with the hour 3, and then the 00 is o'clock. Let's look at a new time. What hand of the clock did I move, Congo Nation? Very good. I moved the hour hand. To what number is the hour hand pointing? Good. It's pointing at the number 11. To what number is the minute hand still pointing? Our blue minute hand. Very good. It's still on the 12. So what do you think the digital clock looks like when it reads this time, 11 o'clock? Very good. On the digital clock, the 11 is on the left side of the colon. Then we have our colon and our 00, which represents o'clock. This digital clock says 11 o'clock. Let's look at another time. Which hand moved this time, Congo Nation? Very good. It was our green hour hand again. Did the minute hand move? Yes or no? No, it did not. It's still positioned at the 12. So what is this time? Remember, say the hour first and then say the minute. 7 o'clock. Very good. On a digital clock, it reads 7:00. The hour is 7. The minute is o'clock. 7 o'clock. Let's move through each hour on our clock. 12 o'clock. Say the times with me, Congo Nation. 1 o'clock. 2 o'clock. 3 o'clock. 4 o'clock. 5 o'clock. 6 o'clock. 7 o'clock. 8 o'clock. 9 o'clock. 10 o'clock. 11 o'clock. And then back to 12 o'clock. Congo Nation, now that we are done our sachet concept, let's move on to our problem set. Scholars, please head your paper with your first, last name, the date, 5/7/20, the subject, math, and your heading is problem set. For number 1, you are going to draw the 4 analog clocks and the 4 digital clocks that you see pictured here. At any time, please feel free to pause this video. So pause the video and draw these 4 analog clocks in your composition book and the 4 digital clocks in your composition book. If you want to turn your composition book sideways, you can to have more space. All right, but this is your first analog clock, your second analog clock, your third, and your fourth. Here is your first digital clock, your second digital clock, your third digital clock, and your fourth digital clock. Once you're finished drawing those 8 clocks, then you are going to match the analog clock to the digital clock that shows the same time. Yay, Bo? So if this clock shows the same time as this clock, you would draw a line from this clock to that clock. Draw a line from your analog clock to the digital clock that shows the same time. This is all for number 1. Yabo? All right, Congo Nation. Let's take a look at number 2. Number 2. Draw an analog clock that reads 4 o'clock. Number 3. Draw a digital clock that reads 9 o'clock. For numbers 4 through 18, you are going to write the time for each of these clocks. Yabo? Our textbook has it labeled as A through O, but you are going to number it 4 through 18. Number 4, number 5, number 6, number 7, number 8, number 9, number 10, number 11, number 12, number 13, number 14, number 15, number 16, number 17, and number 18. Your last question is number 19. What connection does Benjamin Banneker have to today's lesson? Mighty mathematicians, we have come to the end of our lesson. Thank you so much for doing your very best on the lesson and on your problem set. Now take a picture of your Benjamin Banneker Now take a picture of your comprehension questions for our mathematician spotlight on Benjamin Banneker. Also take a picture of your problem set and send those 2 assignments to grade 1 at sfacs.us. I will see you in just a bit for science. Thank you for tuning in. See you soon.